Hello and good morning, good afternoon, good evening, everybody, and thank you for joining. Welcome to the stream. Hi, Patrick, and welcome to you as well, in particularly, obviously, because you're the star of the show today.
Thanks, Alexander.
How are you doing today?
I'm doing well. Thanks.
Good,
How are you?
good. Yeah, it's
Good.
it's good. It's not so hot, so I think it's good. All right. Before we dive in, again, welcome invite to everybody. This is a free conversational session. So if you are watching this live and you have any questions, any comments, any feedback, just use chat and type it in. We'll have a look out for it and see what we can cover during the session today. Either we directly answer or we at least can, if it's a Neo4j related question outside of this topic, at least I try to point you to a direction. But ideally, obviously, we talk a little bit about what the topic is today. And before we do that, I wanted to quickly raise this point. The Nodes 2022 online developer conference is taking place in November, and we are currently looking for speakers. So if you are in the mood for presenting something, have a look at our website, post a link in chat, neo4j.com/notes 2022, and there is the call for paper link visible. So it's anything, right? So you can post anything. I don't know, Patrick, did you attend notes before? Did you join one in the past?
I
Maybe
haven't, no.
you have not. Okay, so maybe you can also you know at least watch it. It's fun. It's nice. It's cool. It's all about Neo4j and graphs. It's from all kinds of developers and sharing projects. Something similar to what we're doing now. Sharing projects, sharing some insights, sharing lessons learned, whatever. Giving a workshop even or some other um, content. So it's nice. And I'm inviting everybody to join and to submit a session now, obviously. But enough of that. Today we're going to talk about Netfrenzy with Patrick. So again, welcome, Patrick. Thank you for joining today. Before we do that, maybe give our audience a few seconds background, who you are, what you're doing, and how did you come to discover graphs? How did you come to pick Neo4j as your tool?
Sure. So I'm Patrick. I'm a penetration tester. I'm currently a Mandiant. I have a background in computer science. I have a degree, and I have a minor in mathematics. So I've taken discrete mathematics and learned about graphs there, all of which I've since forgotten. But now I get to relive that with Neo4j. And my primary exposure to Neo4j was through Bloodhound, the penetration testing tool.
Okay.
Probably the most famous usage of Neo4j in cybersecurity industry, maybe.
Mm-hmm.
And then I adapted that to what we're about to see today, Netfrenzy.
Oh, cool. Yeah. So that's interesting. Yeah, Bloodhound is very recently. I think last week or a couple of weeks ago, I talked to somebody here on the show as well, and we talked about Bloodhound again for access management and for security inside companies. So it's yeah, it's an important topic.
Yep.
Yeah. All right, cool. That's nice. I'll post a link to your Twitter and to your personal blog in chat, so people can look at that. And oops, that was not what I wanted. Can look at that and follow you there. So obviously this link is the crap link.
Awesome. Thank you.
I'll fix that.
Okay.
And yeah, I think with that we can get going. I think you had a few slides to set the scene rather, and then we can look uh, at the tool. All right, here we go. Yes.
Yep. All right. So that's about me. I was
way.
previously with Coalfire. That's where the project was conceived and developed, and I'm going to continue it myself. So I have just one slide on Neo4j itself, in case any information security people here are interested in packet captures, but maybe don't have knowledge, background on
Yeah,
Neo4j
perfect.
itself.
Yeah.
So it's a graph database, uses Cypher query language. Down here, I have kind of the example format for matching a relationship. So the nodes themselves, which are the vertices of the graph, are in parentheses. The edges are relationships in Neo4j, and they use the square brackets. So what we're selecting here is a person who acted in, that's the relationship. And then the final node is a movie. So person acted in a movie. And then in purple here are the attributes about either the node or the relationship. And that's going to be useful when we're importing data into Neo4j about packets and packet captures. We can have metadata there to query.
Okay. Yeah, that's cool. You still have this studio is sharing your screen as info box
Oh,
at the
hi.
bottom. Yeah,
Thank you.
yeah, cool.
Cool. All right.
Yep.
So this is our first look at Netfrenzy. This is just a tiny screenshot, but I'll go into a demo later. At a high level, we're able to see the nodes and the relationships. In this case, it's connections between IP addresses. And what Netfrenzy is not, it's not a pew-pew map. In cyber, we have pew-pew maps. Maybe it's more of a pew-pew graph. That might be a better way to describe it. And it's also not a physical network topology. So what we're modeling is host-to-host connections, not really host to switch to router to switch to host.
Okay.
Packet captures don't really often have that kind of visibility. That's just not captured in a network packet capture. So about Netfrenzy, here's where it lives. These are the links to where it's maintained. The ingestion part is written in Python. It uses PyShark on the back end to import the packet capture, gather all the relevant data about the packets, and then it uses a request to spit it into Neo4j. The user interface is written in HTML, CSS, and JavaScript using the NeoVis library. And kind of the conception of this project, we had a client who asked us to see if their network was segmented properly. So there's various frameworks that require network segmentation. The main one being the payment card industry PCI standard requires segmentation of networks for cardholder data. So you can have cardholder data intermingling with just like computers and stuff. So a good way to so what we did for that project was we were tasked with verifying it, right? So obviously there was network ACLs and firewall rules in place. But to verify it, we had a computer on that network take a packet capture, and we wanted to see if there was any packets that shouldn't be there. And using the normal tool, Wireshark, I like to think of Wireshark as a spreadsheet, and I don't like spreadsheets. When I was doing research for this talk, one of the other videos on the Neo4j YouTube is about Bloodhound, which we already talked about. But one of the quotes in the description of the video caught me. It was from John Lambert. Defenders think in lists, attackers think in graphs, and that's a perfect example of what the issue is here that I'm trying to solve. This is going to be another opportunity for defenders to use a graph instead of a list.
Yeah.
So modeling a network using a list is not great as opposed to using Neo4j and graphs. So a little about the data models before we get to the demo. The nodes in Netfrenzy are going to be IP addresses, MAC addresses, and SSIDs, so broadcasting access points. The relationships between these are going to be connected, so an IP address can connect to an IP address, or an IP address can connect to a MAC address. A MAC address can be assigned an IP address, and of course, a MAC address can advertise an SSID.
Mm-hmm.
And about the attributes for those, so connections between IPs will have a port and a service. MAC addresses, we can actually look up the OUI, so we can get the manufacturer of that network hardware and display that in the graph. that's useful to search by. If you want to say no, what are all my Cisco devices on my network? I can search for where the manufacturer's Cisco.
Okay. Yeah.
Yep. All right. So importing packet captures. You can either feed it a PCAP file or you can import on a live interface. At the bottom here, I'm importing a sample packet capture with 233,000 packets. Based on the source of that data, the packet capture occurred over a period of 4 hours, and it only took 1 hour to import. So it's importing 4 times faster than the actual network is going. So there's good efficiency there. There shouldn't be much dropped packets unless there's like a burst or anything. So in information security, we usually pray to the demo gods before doing a demo.
Yes, always.
Right. So if my demo doesn't work, this is what it's supposed to look like. We're going to be looking at using community and PageRank. So here is Netfrenzy. This is the web interface. By default, it'll show all nodes and connections. What I like to use mainly for large networks is display all connections to and from privileged ports. So that's what we're doing here. Privileged ports is any port below 1024. Those require elevated privileges to listen on. So those will be your HTTP, HTTPS, SSH, Telnet, that kind of thing.
Okay.
So let's go ahead and create the communicates community and PageRank. That'll take about 20 seconds. And while we do that, we can discuss the data set that we're looking at here. This is actually from 1998. DARPA created this packet capture data set for evaluating intrusion detection systems. And I didn't initially think of Netfrenzy as an intrusion detection system because it doesn't really detect anything. It's the operator looking at it that detects stuff. But this was a useful data set to try it out on.
Yeah.
So let's take a look at again connections to and from privileged ports.
So when you say it's not meant to detect anything, it's capturing that probably, and somebody looking at it that has experience and that knows what's going on is will be able to detect something, but it doesn't give out an alert and says, "Hey, here's something going on. That looks strange." That's not what the scope of the tool initially was, right? Is that what if I understood this
Exactly.
correct? Yeah.
Yep. Okay. Yeah. So when an operator is looking at Netfrenzy, the groups become obvious. That's the great thing about graphs.
Yeah.
And then you don't really need to even be technical to see that there's connections between these groups. So even if you're a SOC analyst and your manager comes over and looks over your shoulder, they can point to this connection here and say, "Hey, do we know what this is?" And using a traditional tool like Wireshark, that's not really possible because it's just lines in a spreadsheet. They all look the same, right? So that's one of the
It's very
powerful
hard.
things here. I like to say the eye is the most powerful sensor. Right.
Yeah, that's a good way of putting it up. I mean, of saying it, because yeah, you're perfectly right. If you look at this in a table format, it's I'm pretty sure nobody will be able to detect anything.
Yeah. Or it becomes harder, right? You need to
Oh
know
yeah, I mean, yes.
beforehand exactly what you're looking for, right?
Yeah.
Yeah. So the colors on the graph didn't exactly look like my screenshot. I'm not sure why. But typically these clusters would have each their own color. This is why I should have prayed to the demo gods. But the ones over here do. So if we look over here, we can see these are communicating on port 53 UDP. So that's going to be the DNS service. So this is probably a DNS server of some kind. All the nodes in this cluster, there's some DNS still, but there's also a lot of port 25. So this is probably a cluster of mail servers, most likely. And then over here, the primary port in use, just by looking, it's kind of spammed all over, is port 80. So these are probably normal hosts that are just using web traffic to communicate. And then ultimately what's interesting between these clusters is the telnet service here, port 23 TCP that's connecting these different clusters. Um, so I was brainstorming, how is this tool going to be useful outside of just verifying network segmentation, right? Because if we were looking at this cluster and we said, okay, this cluster needs to be segmented from this cluster, it's very obvious that it's not, right? Because there's connections in between them.
Mhm.
So how else would, like, if we, that's verifying network segmentation is more of a defender thing, right? It's on the blue team side. From the red team side, how could I use this, right? And I'm thinking, how would a red teamer even get a packet capture? Um, so maybe if they had a person social engineer their way into a building um, and use something like this, I have a network tap here. So how this works is you put this in between uh, a connection, an Ethernet connection. So your normal Ethernet connection will go in this way and then come out this way. And then you get to listen on this side, right, and take a packet capture. So that would be one way. Um, Another way, these aren't the only kind of
So,
devices.
sorry because
Mhm.
I mean maybe at least for me this is a new thing and maybe for some of the viewers as well. So if you plug this in, basically it's a listening device and it captures everything you're doing with your on the via Ethernet on on this particular machine that's plugged to it, or if it's a bigger machine then I guess a server or something. Everything that goes through that is then
Yep,
listened on and then basically sent somewhere else as a yeah.
yep, exactly. Anything that comes over the wire gets duplicated from this side to this side, as well as continuing on through to its normal destination. So you can listen with a tool like Wireshark or TCP dump to get a
Mhm.
packet capture from here, and then import it into Netfrenzy.
Yeah.
Um, so there's other devices too, like your typical managed switch can do a packet capture, probably for the more high end systems.
Mhm.
You can also do a span port or a tap. Um, those accomplish the same kind of thing. Um, so I was thinking, as a pen tester, I find default credentials all the time. If I found default credentials on a network device, maybe I could take a packet capture um, and use it here, but then use it Y, right? Um, so as an attacker, if I'm on a red team assessment, I want to be as stealthy as possible. So that means blending in with already existing network occurrences. Um, so if I want to bridge the connection between, like if I have a host in here and I want to get to here, and I had a packet capture, one way I might blend in is by utilizing the connections that are already present. Uh, so if I
Mhm.
want to look like normal network traffic and gain a foothold on this side, um, using telnet from uh, these two connected systems would be a way to do that without setting off any alarms, because otherwise it looks normal. Um, so that's another way, maybe on the red team side as opposed to the blue team side, where this tool is also useful.
Yeah. So if you look at this regularly and you see always these two connections there, and it's not it's that's the usual connection. You don't worry. You're not worried. You think okay, so everything's fine. If all of a sudden a third connection would appear, then then you would look at it and say, hey, where is this coming from? But yeah, if you then could sneak in and say, okay, I'm using the existing connections, then yeah, nobody would
Right.
detect what you're doing. Yeah.
Yep. And it might having this knowledge that these two connections are really the only connections that you should see between these clusters can empower a SOC to apply additional defenses to these connections to make sure that they're not misused. Uh,
Yeah.
so applying additional security at the endpoints um, to ensure that this connection has integrity and confidentiality and that kind of thing.
Yeah, yeah, of course, because then you know, okay, this is the potential way in. So make
Hmm.
sure that this is as secure as it can be. Uh, yeah,
Yep. And so maybe a little more about the interface here. One of
Mhm.
the things I took away from Bloodhound is having built-in queries really empowers the user to um, use the tool effectively. So I have a list of built-in queries here. that you can click on, and it'll just run the query or populate the query bar here. So I'm going to try out another one, top 10 connections by data transferred. So this will show, and our PageRank kind of helps us here. These connections have the most data size contained within them. So these are the top 10. And these are just some of the kind of, it's an example of what you can do with Neo4j using the properties and the attributes on these connections.
So this is using data size, and the more traffic goes through, the higher the rank, and then page ranking it over and to see who are the nodes, or which are the nodes which route the most amount of traffic through. Is that what it is?
Yep, exactly. If my demo worked as it was supposed to,
Yeah.
these arrows would be thicker based on the amount of data transferred. So it would be descending in thickness.
Yeah.
We can take a look at the query here though, because that's what's generating this.
Mm-hmm.
Match a node connecting to an IP address with R, and then we're grabbing the data size as data, and then we're ordering by that data descending. So it'll be from most data to least data, and then we're limiting that to 10 connections. And then we're returning that for viewing here. So that was one of the built-in queries. We can try writing a query here. So let's say we want to find, let's go
Okay. You can
for,
directly type in there. That's cool.
yeah, MAC addresses. And let's search for a certain manufacturer, because that's one of the cool things with MAC addresses. They have an OUI. Manufacturer. And let's look for Oracle Corporation. And then all we need to do is return this node. Will this work? Yep. So this will be all the MAC addresses on the network that have a manufacturer of Oracle Corporation.
Mm-hmm.
And we can also write that a different way, right? Like here we're searching by the attribute here, but we can also do a where contains. So m.manufacturer contains, and let's search for Cisco. And that didn't work. Oh, it's because I'm searching
No,
for
you
M.
need to do, yeah, exactly. N dot menu. Yeah.
Perfect.
Yeah.
So even though we didn't know the manufacturer full name was Cisco Systems Inc., and I've actually seen it where there's different, Cisco itself has different OUI terms there. This would show all Cisco systems. So that's another kind of interesting way to use this tool is asset management. Taking a look at what all types of systems are on your network at a given time.
Yeah.
Cool.
And I guess, I mean, you could, I mean, potentially give more details about it. So could say like online, offline, or other stuff.
Right,
Um,
or seen between a certain time,
yeah.
or has connections between a certain time. That's one of the attributes that we're keeping track of is when was it first seen, when was it last seen talking to the network.
Okay. Mm-hmm. Mm-hmm.
All right. So I'm going to go back to my demo here. Slideshow, current site. Cool. So in an ideal world, that would have had thicker arrows and it would have been colored by groups a little better. Maybe next time. So we can discuss networks a little bit, because actually getting this packet capture to in the first place is tough. A lot of organizations that have flat networks, those are considered insecure because any machine can talk to another machine.
Mm-hmm.
Or they have flattish networks where most of their network is flat, but then they have some secure boundary for all the kind of high value assets. So getting a packet capture on a flat network can be tough because there might be multiple routers, multiple switches, kind of many different places where traffic is going in between and talking to each other. Um, so what I have at the bottom here is a screenshot from Zeek's documentation. Zeek is an IDS system, uh, basically. And in their documentation, they have this nice, what is essentially a graph.
Mm-hmm.
This is a physical network topology where they're describing where you want to take a network capture. So I showed you this network tap. Um, if we want to capture as much relevant data as possible, where do we want to put this, right? So it goes over most kind of Soho network designs and the pros and cons of putting it in any certain spot. But this is the ultimate visible network architecture. This is kind of what you want to have the best visibility. And they suggest putting it at location D. Um, so the
Okay.
pros and cons of that is your wired devices are going to be connected into your switch. You could collect at point E with the wired devices, but you wouldn't see any of your wireless devices. Same kind of thing with point G, but it's the opposite. And also you run into issues with actually capturing wireless traffic.
Yeah,
Yeah,
that's gonna be hard if
802.11.
it's a wired tap.
Yeah, and then between your wireless access point and your switch, again, you're going to be missing your wired devices, but at least you'll have better visibility into your wireless devices. And then finally, from your switch to your router, is going to be the best spot um, because you're going to see each of these devices because the router necessarily needs to have those packets to route them correctly.
Yeah.
Um,
Yeah, and then goes just to the internet basically. So
yeah,
the rest is not interested anymore, and it's the same information basically, I guess. So
exactly. At any of
no
these
new information comes around with the other points.
right. At point A, B, or C, you're not going to have your NAT IP addresses. You're going to have your gateway IP address, right? Um, so that's not going to be ultimately as helpful for tracking down any anomalies or threats.
It's not going to be probably. It's also not going to be possible, right? I guess the you probably won't be able to get at point B or A because this is not your system anymore. This is outside of your system. So this is you would have to go to your
Yeah,
ISP and say, "Hey, can I install this device?" It's like they would say no.
yeah,
Yeah,
yeah. So if you think about an office building, point A is going to be some
yeah,
coax wire on the electrical lines outside. That's not
yeah,
really possible. Point B is going to be probably in a pipe outside your basement.
yeah,
So point D is
yeah,
the best for visibility as well as for actually getting the thing installed.
yeah.
Um, yeah, and as opposed to a network tap, if you have a high end router, it can also provide um, network spanning. So getting a span port, which is going to also duplicate traffic from one
Okay,
port to
yeah,
another. Yeah.
yeah.
So I'm the developer of the project. Some of the challenges I faced and had to deal with were at the beginning efficiency. Um, so some of the data, when we collect as much data as we want, um, some of these items, for example, the data size or the layer of the service that we're observing, um, we want to compare that to data that's already in the database. And that creates an atomic kind of operation where we don't want the data that's in the database to be modified between the time that we read it and by the time that we write to it again. Um, so that reduced some of the efficiency. And the solution to that really is to not collect the data. So if you want the highest speed possible, you want to collect the least data possible or the absolute minimum data that's actually useful to you. Um, so maybe collecting data about the service that's observed on that port or the connection maybe isn't useful because you can see what port number it is and you can just assume. Or maybe you have some other kind of intrusion detection system monitoring for what traffic is actually on that port, or you have deep packet inspection and you have a device that's ensuring that that packet aligns to the service that it's actually providing. Um, so that was one of the challenges there. And one of the options when you're running the Netfrenzy importer is to reduce the amount of data that's collected, and that'll increase the efficiency. That's enabled by default on when you're doing a live capture, just to make
Mhm.
sure that you're um, capturing data as fast as possible, so you're not missing anything or getting backed up. And another thing that we did to speed up efficiency is cache on the Python side. So when we see a packet, what's going on internally is you check out the IP address on the sending and receiving side, and we want to make sure that those are in the database, right? So we're doing a merge, um, but that merge checks if it exists, and if it doesn't exist, then it creates it. Um,
Mhm.
uh, that isn't as fast as just checking to see if we saw it recently. So what the cache is doing is just saying, hey, we saw this IP in the last 20 packets. There's no need to try to merge it. And the same thing for MAC addresses and SSIDs. So that speeds up quite a bit. Get a lot of efficiency that way. And you're more knowledgeable at Neo4j than me. Maybe you could, based on the problem I've just briefly described, suggest maybe something built into Neo4j that would help with that.
Yeah, I mean, with Neo4j, it's the the problem we sometimes face is that it obviously takes a little bit more time to write something than to read something. So the problem you're just describing is trying to circumvent that a little bit. Because just to highlight that, or just to give an explanation why that is obviously when you write something in a graph, you persist that node, and you write all the relationships with that node. So that means it has to make sure that all the node as well as the relationships are written, and then it can say, yeah, I've done that, and then it can come back. Because otherwise, if it wouldn't have done that, or it wouldn't have committed to that, you corrupt your own data. So that's why it takes a little bit longer. And um, and that why it does is then that much faster when you say you want to read something, because you don't have to, you just basically go through the graph and don't have to do anything else. So no more computation is needed by reading, or not much at least. What this challenge is exactly that. It probably is if it's a lot of data, and then at some point you get lots of packets to be written, then your database could be slower than what comes in. And I guess that's what you try to circumvent, and try to say, okay, we limit the amount of data, we make it a little bit smaller, so that then the database won't be clogged, and then won't be like, okay, I need to, or the database tells you, oh, sorry, this is too much now, we need to wait, and then it's creating a backlog basically. So what you could do is basically set up a system in between that is used as a data dump, where it's a system that is very fast at writing. So you write it there, and then from there you pipe it into Neo4j. Obviously, that will create some kind of delay. If a real time system is needed that is actually real time, then this would add a little bit of delay, depending on how you're writing to the dump, importing from the dump into the Neo4j database, how that's set up. But it would obviously prevent you from having the system stopped, because it's waiting for packets, and it cannot read them all at the same time, or cannot write them in quickly enough. So that could be a solution to look at. And then I'm uh, I think there's probably some optimizer as well you could do with Neo4j itself, to see of how quickly can you write stuff, how can you write only the bare minimum at first, so that the stuff is done, and then afterwards add more stuff to it. For example, add more properties, add additional stuff that would create another rewrite over the existing properties. That could be another solution I can imagine. um, that could help. Yeah, but yeah, that's the yeah. If it's real time, and if it's really it's a lot, then it could happen. Um, yeah.
Yeah, those are all good ideas.
Yeah.
Thanks. Cool. So we've already looked at some of the queries, but we can go over some of these again. So looking for connections to and from privileged ports. This is one of the built-in queries. This is my favorite query. So looking for nodes that are connected to each other, where the port is less than 1024 and the port is greater than 0, because I am using -1 and -2 for certain connections. So that's kind of a basic query.
Mm-hmm.
A more complicated query, we also looked at top 10 connections by data transferred. So using the order by and limit to achieve that. And then what I did in my demo, right? So creating the community and page rank and that sort of thing. This uses the graph data science library. So it's creating a graph. It's creating a match on the relationship between that are a match on connected relationships. So it's grabbing the different nodes, counting those, so gathering the number of ports that an IP is connected to another IP on. So if it's connected on to another machine on port 22, 23, and 80, it's going to count that as 3 ports.
Mm-hmm.
And then it's going to sum the number of connections across all 3 of those ports, and that's going to be the total. And it's also going to grab the sum of the data size of all of those. And so the reason I'm grabbing multiple things here is so that we can change what's actually being represented by this page rank. So you can have the page rank show the number of connections, or you can have it show the data size, and the data size was supposed to be in my demo. So then this is kind of just finishing up, creating that network, creating the relationship, and then writing the page rank property and the community property. The community creates the colors for the different cluster of nodes, and then the page rank is for the thickness of the relationship arrows.
Yep.
So this is my final slide. This is a comparison to other tools. On the left, we see the traditional way of looking at a packet capture, which is Wireshark. So in the top kind of pane, you have a spreadsheet with different rows and columns showing the source, the time, the destination, the protocol, and then when you select a row from that spreadsheet, you get to inspect deeper information about it. So every packet is like an onion. You unwrap layers. You can think of it as in terms of the OSI model, but it's kind of just easiest to look at what it is really. So in this example, we have DNS, which is on UDP, which is using the Internet Protocol, IP, IPv4, and then that's traveling over Ethernet, and then the actual physical layer on the wire, and then it shows the data there. So what we're kind of keeping from here, so we're obviously not keeping all the data that's displayed by Wireshark, because it's not necessarily relevant in the first place for the purposes that we want to use Netfrenzy for, which is like segmentation.
Yep.
We don't really need to care whether a checksum is valid or the data length for an individual packet. But we're keeping what service it is, what port it's on, what protocol it's using, and then the IP addresses and the MAC addresses. And this is the traditional way of viewing a packet capture. And there are filters. So you can write a filter that becomes kind of like a query in Neo4j, but you're still not getting a graph. You're still not getting a visual representation of what that would look like at kind of like a higher level than a physical network topology.
Yep.
On the right side,
It's more
on the
like
top,
it looks more like a protocol tool where you see, okay, this is going on, this is what it is. If you want to look for something, or what was that, so like basically either looking back in time or looking at a certain something either causing an error or something else going on, and you can say, okay, here, this is what it is, but it doesn't give you any particular insights. It's more like, this is what it is currently protocolling everything. Is that what it is?
Yep, exactly. It's great as a protocol analyzer, debugging network traffic, um, but it's not an overly visual tool, and it's not
Yeah.
something you want to look at for more than like 5 minutes.
I can
Yeah.
no. Yeah.
So on the right, we've already talked about Bloodhounds. Bloodhound is kind of the premier example of using Neo4j in the cybersecurity community. Um, so a lot of the data that we kind of gather is similar or analogous to what is collected by Bloodhound, right? So Bloodhound will have nodes for computers. Um, it'll have connections between the computers because they're part of the same group, or um, there's a session between computers. Um, but what we gain and what we lose are actual network connections. For example, HTTP, SMB, that kind of thing. Whereas in Bloodhounds, you're really gathering access control data, so information about um, the properties of and privileges of a user or of a computer or of a group. Um, and I've kind of considered, merging some of the data into Bloodhound, but I don't think the actual uses of each tool would overlap enough to really be relevant to have all this data in one tool.
Hmm.
Um, yeah, that's something I keep thinking about.
So
Um,
you would have a tool that tracks access management, basically user access to certain points, as well as web traffic or network traffic, and then you could see, okay, who is. I mean, it could be potentially could be interesting saying who is accessing what and how do they access it, or taking which network path. And with that, they can see, okay, this user is accessing this whatever folder, or say the right directory, why are using this and that network path, and then you can maybe find out, okay, the user has no rights to access this directory, but via this network path they are kind of circumventing the access management, or other way around, the users should have access but they cannot because they have some network path that's blocked for them. Could that be a use case?
yeah, sure. And one of the things that can be pushed out by Active Directory group policy is firewall rules. So understanding um, if if a domain controller is pushing out a group policy rule about a firewall rule, and we can verify that um, there is in fact a connection that's opposed to that firewall rule. So if, let's say,
Hmm.
port 80 is limited on a host, but we see a connection from port 80, um, that would be an interesting anomaly to look at. So
Yeah.
maybe that rule isn't getting applied correctly, or maybe um, a rogue admin on that server has disabled that rule
Someone got
somehow.
creative.
Yeah. Um, and then on the bottom here, this is from the tool ntop. Um, it looks very similar, and I
Hmm.
thought they would be using the same exact libraries, but they're actually using a library called Stretchy, and it's not really a graph database; it's graph data, but I feel like you need to be able to query it to call it a database, and it's not really queryable. So this is
More like a
actually,
visualization in this case, then instead of actually being represented as a graph. I mean, it's a representation of a graph, but it's not the graph data that's there.
yep, exactly. This is actually a physical network topology, which is one of the things I said um, Netfrenzy isn't, right? So this is
Hmm.
using SNMP and LLDP to determine what devices are physically connected to each other. That's data that we don't get typically from a packet capture itself. Um, this is data that's using SNMP, so you're reaching out and querying each individual computer, hey, who are you connected to? As
Hmm.
opposed to listening and observing what computers appear to be connected to each other.
Yeah. Yeah, I guess, I mean, this is another interesting layer, right? I mean, if you has a different use case, has a different application. I guess if you are setting up your network and you want to know where that some server is faulty or whatever, something is not right, like you said, okay, there should be a connection a bit between these two machines, but something is not working, then you know, okay, where is the location, or who is else connected? Can I at least in the meantime do some rerouting of traffic? And I say, okay, let's you use this other system for now, and then I go and fix whatever's broken. But that's more like the physical representation and not the actual traffic.
Exactly. So now might be a good time. Are there any questions in the chat about Netfrenzy?
I just posted in chat. So again, I'm happy to relay any questions forward to Patrick. I haven't seen any. So if you have any questions on this tool or anything else beyond that, please type it in chat. Yeah, um, nothing so far.
All right. I mean, otherwise, it's been a pleasure talking to you, Alexander. I appreciate you having me on to discuss Netfrenzy.
Thank you very much. No, it was very cool. I mean, you said you changed roles. Does that mean what's the future for the tool? Do you have a future for the tool? And what's your next project? Maybe if this is no longer your primary focus.
Right. So it was previously developed at and maintained on the Coal-Fire Federal GitHub. Um, I've since joined Mandiant. Uh, because of the licensing, I won't be contributing to it in my official capacity at Mandiant.
Hmm.
It's licensed under AGPL, and companies are averse to having AGPL code infect the rest of their code bases. So I'll be contributing to this in my free time because this is my passion project. So you can follow it on my personal GitHub. Um, Let me go to the slide with my personal GitHub on it. So it'll be here. You'll find it on my personal GitHub. And I'll try to maintain it. There are a list of issues that aren't really, most of them aren't like bugs, but they are like tracking potential future features that I want to gain input on, so to see if they're useful, and then implement them if I think they're relevant to the tool and relevant to the uses. Um, so, for example, when we're looking at the user interface, we were just looking at an HTML file, and I think it might be a little more powerful if there was an actual web server um, that was hosting that file, because then we could have interaction with the file system, access the configuration files, that sort of thing. Um, Additionally, there's more data that I want to pull from the packets themselves, um,
Hmm.
which of course comes at the expense of efficiency. Um, but I think, especially when you're importing just a packet capture file as opposed to capturing on a live interface, um, having additional information there. For example, host names. Host names, like right. So we're looking at IP addresses, and on certain networks, maybe that's not so useful. Maybe every host has a nice host name that's uh, good to search by, for
Hmm.
example. So if you have a fully qualified domain name on your internal network, um, that would be a nice thing to search by. So that's one of the future planned features for this.
Cool. No, that sounds interesting. Yeah, I was thinking a little bit more about the importing and the data loading, and I think another potential way to save time and to gain performance would be to shard it, to use Fabric, and to use, like you said, we have wireless devices and wired devices, and maybe you have even another a layer of if you know if you know where the location is, you could say, okay, floor 1, floor 2, floor 3, or something of your network, or something else, and then you create a separate graph for all of these, and they would then be connected on top. But then the loading would be quicker because they don't have to. They wouldn't go in all of the network basically, but they would only be in their local spheres. So that could potentially
Hmm.
help.
Okay. Yeah, that's a little beyond. I'm not an expert at Neo4j.
No, I mean
And in fact, I made this
I
project because I want to
this
learn
goes
about
beyond
it.
what I do as well, but
Yeah,
I know that it's possible. So yeah, I how it's done exactly is I'm not too sure, but yeah.
cool.
Okay, cool. We have Ankush says thank you, a great presentation and very informative. So yeah, you're welcome. And
Thanks for
Mark
watching.
says nothing to do with graphs. That's okay. But is the packet sniffing device detectable on the network?
So that's a good question. These devices don't really add much latency because they're a physical layer. Um, uh, you will see, you actually need to plug this in, right? So you need to unplug a wire, plug it in, and then plug in another wire, and then plug it into where it's supposed to go. So you can potentially see that connection be dropped, right? So that's one way to detect it. Um, if you're actually looking at a router or a switch, and you have default credentials and you're capturing packets that way, um, you would be looking at the access control logs for that system to see if there was any unauthorized access. And of course, keeping track of any default passwords on your network or how passwords are used and how accounts are used. Um, so that'd be another way to kind of detect that kind of attack.
Yeah, but it wouldn't get like other devices you plug into your network wouldn't get a an IP address, I guess, and by that being very clear, say okay,
Yeah,
new
yeah. These
new
are layer
item just
one.
added to the network. Oh, IP sniffing device. Oh well, what is
Yeah,
that?
yeah. These wouldn't have a MAC address or
Yeah,
an IP address. It would just be a physical layer.
yeah, okay, yeah. So it is somewhat sneaky. So you would have to pay attention definitely. Yeah. Yeah. Okay, cool. Well, I think that's all we had for today. Again, thank you very much, Patrick, for taking us through that and showing Netfrenzy. I think it's a very cool tool. Um, do try it out yourselves if you want to. Check it out on GitHub and give it a spin. Give the feedback obviously once you tried it to Patrick, so he can improve maybe. Um, and then yeah, with that I think again thank you for watching, thank you for spending the time, and we'll be back or I'll be back on Monday with Michael next week, but tomorrow my colleague Adam is doing an Ask Me Anything on anything related to JavaScript, Node.js, TypeScript, and beyond. So he's live streaming for a couple of hours tomorrow afternoon, so 2 to 6 p.m. Central European time. So if you're interested in all of that, join his live stream tomorrow. Of that, yeah. Thank you for watching. Take care, everybody, and see you soon.